Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. This episode of the New Stack Makers is brought to you by Twistlock, the complete cloud-native security platform protecting containers, serverless, and Kubernetes applications against threats. Twistlock is the only cloud-native security platform to provide real-time threat intelligence and management through the application development lifecycle across every cloud-native environment. Hey, it's Alex Williams, the New Stack, here at KubeCon plus Cloud Native Con in Seattle, Washington. 8,000 people here for this event, but we're in the boardroom, and I get to have a conversation with Alexis Richardson, CEO of Weaveworks, and Andrew Clay Shafer, Senior Director of Technology at Pivotal. How are you guys?
Well, hello there.
Hello.
Better than I deserve.
So our discussion really is about service mesh technologies, and I wanted to talk about service mesh technology, and then
say it very fast, many
say
times.
Say it very, very fast. Service mesh, service mesh, service mesh, service mesh. I'm not going to try that again. And so, but I want to talk about service mesh, and then I want to talk about this idea of GitOps and how it relates to service mesh technologies.
Okay.
So what I would love to do is just get a level set. Maybe, Andrew, you could help us. Can you tell us about the roots of service mesh technologies? Because when John Morello of Twistlock wrote a story for the New Stack, and he was talking about kind of the earlier kind of thinking about, networking and how you would think about networking kind of in, terms of on-premise architectures, right? And now I'm just curious on how you view the roots of service mesh kind of dating back 5 or 10 years.
I think that there's patterns that emerged in all of these companies that we'll call, for lack of a better term, cloud native, where they're doing some kind of client-side load balancing, right? So there's an open source project from Netflix that does this. If you go talk to these people, inside, behind the veil of different companies, I remember having a conversation with someone who had built Uber and did this with HA proxy. People did this with Nginx. People did this with, whatever the kind of proxy technology du jour was before there was containers, right? So you have a bunch of VMs or even bare metal, and then you've got some way to do this kind of client-side load balancing setup inside of that firewall or whatever your perimeter is, and then as you get to set that up, you start to have these problems of like, well, what's the policy, right? Like who should be able to talk to each other inside of this? Generally the cloud natives tend to have a soft middle compared to maybe our more enterprise-minded friends. But this pattern had emerged as kind of this dominant paradigm where you have a local process that's got some notion of the routing that's available to it, and you basically pass everything through these proxies. That's something I saw emerge across a lot of different projects and a lot of different companies. And then similar to how you see the emergence of the container scheduling, this is just taking and codifying that pattern in a API or a specification that gives you a common way to configure these things. At least for now, it seems like the dominant proxy is Envoy, but it doesn't necessarily specify it has to be. And then there's also more and more of this sort of functionality that's being put into the sort of, some of it's service mesh, some of it's like the sidecar all the things sort of thing.
Sidecar all the things.
Sidecar
I like
all the
that.
things. So we're like sticking more and more of this functionality. So it's like you have this routing thing. Okay, well now we need to solve for policy for who can talk to each other, and that's one thing. And then okay, like what about tracing? Okay, like we want to figure out like how this stuff's actually talking to each other. We let it talk to each other. Now let's sort out what happened after the fact, maybe. And then you have things like circuit breakers or these other patterns that were kind of the cloud native patterns that, you could go through each of the open source projects from Netflix or what have you, and more of that stuff is kind of being put into this platformified routing layer. And that's sort of where we are today, is like everyone's excited about it and maybe putting too much stuff there, but there's a dominant paradigm that emerged spontaneously as a evolution inside of all these companies, and now it's sort of being collapsed into a shared solution that everyone's sort of agreeing on. This is the APIs, this is the primitives, this is the functionality that we want to have at this layer.
So how are you managing this 5 years ago? You were just basically managing those load balancers then in many ways, weren't you?
So in some ways, you could think of Istio as a configuration management solution for Envoy. Like that's one way to put it. And I heard other people talk about that with similar language. So in the context of doing a deployment on these older, HA proxy or whatever style client-side load balancing, then maybe you had an API if you're sophisticated. Like look at some of the stuff that Netflix did with I don't know, there's a bunch of things like Zool and Ribbon or whatever,
right.
To do that. Or you look at
here comes Zool again.
Just like doing it with Puppet or Chef or something.
Right.
It's like, so you put
right.
you basically inject the routing table into the deployment when you swap the thing out, right? So if you add a new member to the cluster, then that has to be accounted for in the next rev of the routing table.
So one of the things we are seeing is more application-centric approaches, right? Would you say that's kind of would that be accurate?
What is an application-centric approach?
Well, I mean, one of the ways you think about it is like is with the network, right? The network used to run the machines, and now it still does. But you have kind of this new substrate.
There are still networking people who believe that they can add value to the application layer. It's a really kind of mad delusion.
So we got into this weird place with SDN, and maybe this is a diversion, or maybe it's a critical part of this conversation. But there's sort of like this SDN that emerged with some of the stuff other people are doing. It ended up in this place that some of the quote-unquote DevOps tooling ended up, where the people that understand the network didn't necessarily want to do things in this new software-defined way, and the people that understood the apps don't understand the networking, right? So I think that the common theme that we're seeing emerge in these patterns is not so much that it's application-centric, it's what you're trying to do is give everyone the abstraction that allows them to do the right thing by making it the easy thing. Right, so you're giving the developers and maybe this is application centric, maybe it's not. You're giving them the ability to deploy their apps into this fabric,
right,
where the policy is defined maybe organizationally, or people who understand more of the security side or some of these other things. But you make it easy for them to do the right thing, right? So when you're talking about continuous delivery and like some of these other things people want to talk about, if you go through and set up the best software-defined networking, but you don't have anyone who's like doing continuous delivery and testing and like being able to do that programmatically, then what you have is essentially a software-defined network that everyone sort of sets up by hand and then backs away slowly, right? So if you really want to take advantage of what's happening, you have to get to these higher-level abstractions where the right thing is the easy thing, and the app people can care about the apps and it does the right thing, and the network people can care about the network and it does the right thing.
If you want to go fast, you need to empower the developers who make the changes to the apps to do that more often. With their own ways of checking that the tests pass and that everything is correct and good. So that means that you need to take some of the operations folks out of the flow of delivery a little bit, meaning...
But the operational best practices are being baked into the platform.
Correct.
It's not like you abdicate responsibility for those kind of considerations. It's just that you're letting the software do the right thing for you.
But you don't need the interaction between the people, the dev team and the ops team every time you make a change.
That's the GitOps then.
Well, just generally with many changes.
That has nothing, like the tooling doesn't matter,
well, yeah,
or
right,
otherwise.
You're right,
But it's like we don't want to have, if you think about this thing, what's the rate limiting step? If there's a change management checklist that requires people to sign a thing, that's your rate limiting step.
Yeah.
Right? So if you want to go fast and you went and built all this pipeline stuff to do the right thing, whatever the tool is, we like Git, I love Git.
Gyro ops.
Then yeah, SVN ops or whatever. May God have mercy on your soul. Then you have this tooling, but you still have your cab. You're going to go have like people check a box before you can do anything. Then you're not going to go any faster. Right? Like it doesn't make sense, theory of constraints or whatever you want to frame it, it doesn't make sense to minimize anything but the biggest constraint. And if your biggest constraint is your change management checklist with another human, then let's find a way to automate that and then do that sensibly. So it's like here's the 80-20 cases. the 80% should be 100% automated, and then when we get into these other areas, maybe we want to have a little more scrutiny. We want to have a little more ceremony.
Sometimes you put the gate down and you say no.
Just because it's an exception, we want to do the right thing, so we're gonna be a little bit extra
careful.
So
if you're a bank, you might have changes to applications, and if it's the front end, you let the UX team see it. Otherwise, the dev team just goes straight on ahead and does it. But so it's the desire to go faster and separating off the human beings from getting in each other's way. That's one factor. I think another very important factor is that these bigger companies tend not to throw anything away as they turn into enterprises themselves. So you need to have a service layer where you can roll out different versions of services that run alongside each other. And there are so many reasons you might want to do this. Obviously, A/B testing is a classic example. But if you go talk to Google, they'll say, we still have things running from 1999.
Just to cram more buzzwords in here, so this comment he just made about enabling the people in these work streams to go faster, that's kind of the whole point of microservices too, right? You're trying to decouple the releases in these independent services, not so you have more microservices to monitor and manage and deploy or whatever, but so those different workflows of humans aren't gated on each other's deployments.
What is the demarcation between Envoy and Istio? I mean, can you help us kind of just clarify for people out there? Because
it's a control plane.
Yes, I think that's it. So when I said Istio is a configuration management tool for manipulating Envoy, Envoy is the proxy that's going to run as a sidecar next to whatever your service is. And then Istio is this global kind of manipulation of all of those different proxies across it's orchestrating. It's essentially, so you kind of have Kubernetes is this orchestration layer for the deployment of the containers.
Right.
Istio is this orchestration layer for the routing of the service mesh.
So you need the orchestration to have the automation.
Right.
Based on the instructions that you provide through your configuration files. And then the orchestrator does the rest.
And then at the bottom, it's all IP tables.
And then Envoy, or Envoy as we like to say in London, is what Matt calls it universal data plane, which I think it'll do fine. But it's supposed to be everywhere. It's supposed to handle data and tell you where to put it, and also have the ability to hook in circuit breakers, billing, policy, all the things that you need for enterprise.
So how are you seeing your customers starting to use service mesh technologies?
Istio, we don't see much Istio in the wild. We're seeing a lot of people talking about using it. What we're seeing is people doing testing with it to see how it performs. And I think that there's still a little bit ways to go before people start rolling it out in production due to concerns about performance. One of the things in the larger companies, whether they're web shops or traditional enterprises, is that they're going to stick a load of stuff through this layer. And if the throughput isn't going to handle it, then they've got problems. So they don't want the services to go down. So they'll hold off deploying it and just do things more manually until then.
So I think you're seeing lots of Envoy being deployed, and that's already kind of production hardened in use a lot of places.
Yeah, I'm referring to Istio. I think Envoy, yes.
And then Istio, I think Istio at this stage in its evolution, similar to the evolution of these other projects, Kubernetes being one of them, is in an early phase. There's still an operational burden that Istio imposes on you. I think that there's not clearly demarcated cases when you should use Istio or why you need Istio. There's definitely interest, and just to kind of frame that, I was recently in China, and I ended up in conversations about what people are experimenting with, and this is Beijing, very conservative bank, and they were doing science experiments with Istio, right? So there's definitely a desire for this problem to be solved. I think that when you look at the way Istio's own kind of management works and the operational burden that Istio imposes on a team right now, that there's maybe reasons why you want to evolve it. You want to see it evolve and mature a little bit before that's the thing you go to production.
But if you take out Istio and look at the other mesh options, so we're seeing a very good reception to the Amazon release of their app mesh. Obviously, it's just out a couple of weeks ago, so probably no one's using it yet, but we saw a heck of a lot of customers in the last 12 months on AWS raising problems with us about we're using Kubernetes, we have load balancers, we've got other intermediaries, we've got this, we've got that, and we've ended up with a mess. And now we have things like peak demand during holiday season, shopping, e-commerce, causing things to fall over, and we don't know where the bottleneck is in the network stack, hitting the app, coming in from the outside world into our Kubernetes stack, and that's causing us a lot of stress. So we would like something that's optimized, that's observable and controllable. So I think App Mesh could be a good solution for them, and that, of course, is based on Envoy. It's just a huge Envoy tier, essentially. Then I'm impressed with the interpretation of Service Mesh from the HashiCorp team, personally. I like the idea of tying Mesh to console and making it about services and service discovery, because that makes it very explicit that what you're saying to people is you discover services, you use services, and you permit people to use connections from A to service B to service C or not. So it's all about who can talk to who, and that's one of the key properties of the mesh, this sort of firewall concept.
The firewall concept, right. And the proxies, right? You know, and thinking about how the proxies work then. And so when you think about that in terms of, you know, you bring up AWS and their service mesh, when you're thinking about kind of like, you know, a more kind of distributed kind of method of thinking about Kubernetes, maybe, you know, there is that capability to use, you know, to run across, you know, different cloud services. Is there any kind of integration challenges that will come when you're thinking about AWS and other
I know a
environments?
number of people who are starting to think about the service mesh of service meshes problem. So when you think about the way
Superglue.
Yeah. There's a few people working on interesting angles here. So you have the cluster with this localized routing table, but now you have multiple clusters, maybe for, you know, whatever reason, and how should they have, you know, some notion of each other, and what's the proper thing to do with, and it gets very complicated because now you have not just the notion of the permission, but also like the locality of the data and like a bunch of other things to think about. So
Yeah, I mean, if you think about, imagine what it must be like to run Google. They've got this global business. They've got users coming in from all around the world, from phones, from computers.
Right.
The request hits Google some endpoint somewhere, and the job is to then get it to the place where that request can be serviced. It might be routed around the world. And as more companies use technology for customer services, more people will have this problem, and that's the service mesh and the integrated federation of service meshes and whatever happens after that.
And latency becomes an issue, doesn't it?
absolutely, yeah, absolutely.
Yeah, huge latency issues.
Everything comes down to hard networking and storage problems, and like how fast can you do a thing when there's the speed of light as a limit, right?
Going back to your point earlier about sidecar of all things, you know, what happens with these things when you get to the stage of just trying to integrate everything through services is the user request comes in, it hits a load balancer, it then gets put into a sidecar which turns it into an internal request and routes it to another load balancer, which then passes it to another sidecar, which unpacks it into something that can be understood in the format of the service, the thing that's going to fulfill that service, which then provides an answer, and then you do the same thing in reverse. You've got like 8 hops.
Yeah, the hops are
and it's going to punish you if you design it badly.
How do you think about the security then in a context like that, where it's hopping around so much? And you know, and
well,
I mean,
and a lot of what we're talking about, those hops are really just this abstraction. When you're talking about a container and a sidecar next to it, it's all really just processes. They're abstractions on the same machine. So it's not. It still costs you, but it's not like you're. I mean, that's actually the whole point of the Istio policy is to control what's there. But there's still a bunch of unanswered questions. There's some other stuff that's interesting, which may or may not eventually be part of this conversation, which is the Cilium BPF stuff people are starting to do, where you have a different construct for managing this network stack at a lower level than like IP tables is doing, or maybe not a lower level is the right way to think about it. So like a higher level abstraction that's getting you that kind of access to control.
You're trying to
network.
Expose at the application tier, at the policy layer, where the user requests are coming through, properties that can be then implemented in the Linux kernel itself, so they can be executed.
But for the most part, these hops are like self-inflicted, right? And it's like a self-contained thing that's really, in some sense, one entity. You just happen to like insert more sidecars into the mix.
But I think it's fair to say that these architectures arise due to growth and complexity. For many users, they're going to have smaller, more compact, less complex architectures, which shouldn't suffer from these problems.
right.
I mean, I think there's an argument to be made for just keeping it, tighter and maybe Envoy only for certain types of things, right? Like you don't need to have especially in things that are latency sensitive, performance sensitive. You don't need to have this ping pong Plinko thing to get your request back.
So, shifting gears a little bit, the developers and the challenges that they face, right? And with these very new complex kind of environments, and you guys have been discussing this idea of GitOps. What is the story there, the narrative about the intersection of these GitOps practices with these new service mesh technology? Perhaps you could just explain for people what you mean by GitOps. Alex.
Sure. So GitOps arose as a term because we started using it inside Weaveworks to describe what we were doing, which, as I've said many times, is only a few percent of everything that we do is new, building on top of DevOps ideas originally popularized by Andrew and his friends in the world of Chef and Puppet and immutable infrastructure that came after that, and then orchestration, and really pulling it all together to have a few very simple ideas, which are: one, you have a complete state of the world described in ideally a Git repo and container image registries, and then you have a running state of the world, and your job is to compare the desired state with the running state and try and prevent drift and keep them converged and aligned with one another for the things that you want to describe. Okay, and this idea, as I say, is not novel. It's been around since the early 90s when CF Engine was created by Mark. But today...
It's control loops from robotics. It's like all this control theory from way back in the day.
Exactly. So that's the core idea. That essentially describes what Kubernetes is doing as an orchestrator. It knows what the system should do, and it tries to keep the system conformant with that description. So then the question arises, how do you do this for services? And with services, the problem that you have is that you don't have a single deployed instance. You typically have several releases that might be running next to each other. So you need a way to describe all the different releases and the relationship between them. For example, if you do a canary, then everybody knows what a canary is. You release a very small amount of traffic to one new version of a service. You measure whether or not it's doing what you want to do. And if it is, you'd release more traffic to this canary, and it starts to become your main release. And if you don't like what's happening, then you pull back and you take the traffic back onto the old release, and you then release a new version later. And also,
which becomes easy if you control this routing layer.
Correct.
Algorithmically.
So this is called progressive delivery, and it encompasses things like feature flags as well, which is how people are going to do things in the future. So then the question is, what is the description of that state? So that's right now where we are finding challenges, is how do you describe parallel releases of services?
This notion of version negotiation, there's not a canonical solution.
Right.
Like everyone sort of arrived on as the agreed upon way to do it.
Yeah.
There's a few different tips and tricks people do, but they're not all compatible with each other. So.
Yeah. So I mean, for example, Istio has config files which tell you what the services are that are potentially being released, and how to weight traffic routed between them. So when you make changes to Istio to change the weight of the traffic being routed away from the old service to the new service, you're also updating your config files, essentially. So then, other people have other approaches. Declaratively. So you're saying, this is the correct state of my Istio machine now. And then off you go. So we've been experimenting with this. We released something a few weeks ago called Flagger, which is kind of fun to play with. It's a Kubernetes operator. So you deploy it to Kubernetes, and then it assumes that you're running Istio. And it basically tells Istio how to automate a canary release. So you give it a set of rules like, start with 1%, flow this much traffic to the canary. If the metrics are over X, then carry on rolling out. If not, then roll back and retry this up to 10 times. So that's a simple algorithm for doing a release. And that essentially helps you to automate stuff that previously was done manually by describing it and let it be orchestrated by Flagger, Istio, and Kubernetes.
Flagger is related to feature flags then? And why do you call it?
It's inspired by feature flags, and I think that it should support them in the future. But this is just one of many techniques that people can do. But the Kubernetes opens up this world of doing things this way.
But more algorithmically. Like, people have done feature flags and canaries for 15, 20 years.
Right.
It's just becoming more of a unified solution. Everyone can reuse the progress.
Right. Launch Darkly, though, for example, has done
a feature flag product.
Right.
Yeah.
Right. And they built it on a streaming architecture, as I understand, to do that.
Yeah, so LaunchDarkly, if I understand correctly, you may know better than I, Andrew, their product doesn't require you to use Kubernetes. It can work with all kinds of things, which is a good thing. But as more and more people adopt containers and orchestration, I think the tools that support these techniques like canaries and feature flags will become things that extend the Kubernetes stack rather than being separate tools.
The goal of feature flags to me is there's this negotiation and like having multiple versions in prod, but there's also this notion of decoupling the release of software to your systems from the release of software to your customers, right? And so you can do different things when you put it on the servers and maybe even run the queries against the data or whatever and see how it impacts these things, but you're not showing the customer. It lets you learn and do science in production with these features before you give them to your customers, and then you can start to say, okay, we're going to shift 10% to the live traffic, and then go through.
So you're looking for the patterns then.
You're looking to do science. Like you don't want to do, in my opinion, you want to make decisions that you're confident, and you want to get to a certain threshold of that confidence by measuring.
And the measurement could be a technical measurement, like does the latency change, or it could be
a behavior measurement.
Customers, are they happier? Are they buying more? Like you might be measuring that using a separate tool, and so therefore going back to the GitOps reason why you might use GitOps, you want to have an audit trail of the changes. So as you update the rollout and then divert more user traffic to the new feature, you'd like to know that happened at 3:12 p.m. on a Friday, and then you go and look at your logs of customer behavior, and you can say, oh, we can correlate between the change here and the more money coming in.
It establishes a KPI.
Yes, it gives you a standard framework to test the behavior, A/B test, whatever you want to call it, and say, okay, this is better for our business.
So that becomes very important to developer.
Very, very important. And these would
if you care about your users.
If you care about
and their
your
behavior
users.
and the money that your company makes.
Right. Yeah.
These are, not everyone does.
But that if you don't care about your users, then what do? I don't know. That's another story.
That's a diversion from.
I'm not going to say anything right now.
There's a couple.
Suppress yourself.
There are some companies you could work for.
In fact.
Oh yes. Well, good. Well, so this is still a very complex subject matter. I mean,
it's nascent and emerging.
Really is.
It's new.
So going forward, what are the things you're hoping to get clarified almost in your own thinking? I'm curious on that. Like, what are the things you're thinking about, going forward? Like, they're trying to clarify in your own mind about the approaches and, how we're thinking about these service mesh technologies and GitOps approaches.
I guess I'll start. I think that there's a little bit of a tension right now in the kind of Istio progression where maybe people are trying to put too much into these sidecars. We already talked about the additional latency, but there's this operational burden that's creating, and maybe it's not the best solution. So finding that balance between what the proper layers of separation and abstraction are to do these things. I think everyone sort of has a little more clarity about we want to be able to do these things. We want to be able to do service discovery, circuit breakers, tracing, all these things, but where should that live? What's the most performant, or what's the trade-off that we make? Everything in these sort of engineering questions is a trade-off, and I think sometimes you see, the pendulum swing with the fashion of the day. And right now, everyone's excited about cramming as much stuff as possible into the service mesh, and I'm not sure that's the best solution for everyone. And maybe some of that stuff will kind of get backed out and like end up living somewhere else.
Yeah, I mean, we didn't mention this, but the service mesh and in some ways aspects of Kubernetes represent the resurgence of a point of view from about 20 years ago or 15, 20 years ago, which was the early days of enterprise Java and the early days of service architecture, when I think everyone got excited about the potential for the internet and the web and these new businesses and thought we can do so much more.
Rightfully so, right?
Yeah, rightfully so. And then they tried to apply it to everything rather prematurely. Right. And you ended up with these people who are building these overcomplicated architectures just for the sake of it, because everything was over-engineered. And you can see a lot of those patterns still in the worlds from ESB and SOA, still in the worlds of
engineers going to engineer, right? Like
engineers got to engineer.
You can really do yourself some damage by having all of these extra parts that you didn't need. So I think that's one question. I think the other question is, how do you make this stuff simple for people? I mean, I believe that the key KPI in our industry is how many developers. are available to build these new apps for the businesses to be happy, because you have no shortage of marketing people coming out of college with great ideas for how to make money online now. But how many developers are there who can make those ideas a reality? And the answer is not enough. So how do we have more developers able to do more cool things? And the answer is not by growing more developers in the developer vats, but it's actually by making the tools easier to use.
The developer
We
vats.
can also grow more developers in the vats.
Yeah,
but-
come on now.
Yeah.
I mean, pods, right?
They do come out in pods now. That's one of the great advances from Google.
You know, I mean, at night they open up, right? You
Yeah.
know, and they go to work. Right?
It's amazing.
Yeah.
Don't feed them after midnight.
They sing.
Well, this has been great. Thank you guys both for taking some time to talk here at KubeCon. It's been I've enjoyed
Plus
this.
Cloud Native Con.
Plus Cloud Native Con. KubeCon plus Cloud Native Con.
Thanks
yes.
for having us.
Thank you very much. Thanks Andrew.
Guys. This episode of the New Stack Makers is brought to you by Twistlock, the complete cloud-native security platform protecting containers, serverless, and Kubernetes applications against threats. Twistlock is the only cloud-native security platform to provide real-time threat intelligence and management through the application development lifecycle across every cloud-native environment. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.